All right, good morning, guys. I'm sorry I'm not there. You need to rip out pages 207 and 208, but I did print those out for you, and it is hole punch for you, so you can follow along as I'm going over our lesson 5. Feel free to pause it at any point if you need to catch up on the writing. If I'm going too fast for you, you can always replay it. But I'm going to be going through 5.1, 5.2, and 5.3, so just 2 quick pages, okay? So we're doing lesson 5 for introduction to linear relationships. We've been talking about graphing, tables, all that kind of stuff already. We're going to start with a quick number talk for fraction division. 2 and 5/8. I want to turn that into an improper fraction. So I'm going to turn it into an improper fraction to make it a little bit easier because you're dividing it by a half right now. So 2 times 5 plus 2 times 8 plus a 5 gives me 21 on the top. And I still have a denominator of 8. If I want to do something different than divide by a fraction, I know we really don't like dividing and we really don't like fractions. You can multiply by the inverse. So that's going to be the inverse of whatever is after that fraction. So 21 over 8, it stays 21 over 8. If I flip over 1 over 2, you may have seen me draw a double-sided arrow, you may have not. Multiply that by 2 over 1. I flipped over the 1 over 2. So 21 times 2 is 42. 8 times 1 is an 8. And we're just going to divide by 2 real quick. I'll show you why we're not dividing by 4 or by 8 or something else. But that's the only number we can reduce by. That gives us 42 divided by 2 is 21 on the top. 8 divided by 2 on the bottom is a 4. If you put that in your calculator, it'd give you about a 5.25. We could call it a 5 1/4. If you want to think of it kind of like 7th grade kind of way. Okay? Again, feel free to pause it when you need to. I'm going to move on to 5.2. We are stacking cups. It says we have 2 stacks of styrofoam cups. There's a visual there for you already. One stack has 6 cups, and it's a height of 15 centimeters. And another stack has 12 cups and has a height of 23 centimeters. So it looks like this here is a 23. It looks like this here is a 15, right? So it says how many cups are needed for a stack with a height of 50 centimeters. So we could do a quick table. So we're going to think about some differences. I talked about rise and run a little bit recently. Number of cups is your input. You can't figure out how high your stack is until you know how many cups you're stacking. So your output would be the height in centimeters. So again, X is your input, Y is your output. I talked about this on Monday. So they told us 6 cups had a stack of 15 centimeters. They told us 12 cups had a stack of 23 centimeters. So from here, it's really just noticing the pattern or whatever's happening. Going from 6 to 12, I added 6. Going from 15 to 23, I added 8 for my height. So I want, a height of 50 centimeters? That means this is going to need to get to about 50 down here. Somewhere around here is going to get around 50. So I'm going to try the same pattern because we already know if we do plus 6 and plus 8, it's still more or less proportional or staying in balance. So if I add 6, it gives me an 18. 12 plus 6 is 18. Add 8 again. Gets me a 31. I haven't gotten to 50 yet, so I'm going to keep going. I'm going to add 6 again. That gets me a 24. I'm going to add 8 again. That gets me a 39. Still haven't gotten there. That's okay. I'm going to add 8 one more time. Let's see. I'm going to add 6 one more time, and we're going to get pretty close. So 24 plus 6 is a 30. 39 plus 8 is a 47. So that proportion that we talked about, the rise over the run, all the x's that I'm doing that I'm adding, that's my run. All of the height and cups that I'm adding is my rise. So rise over run. From what I have been doing so far, it's 8 over 6. If I add 8 again down here, it's going to be way too big. So let's say I divide by 2, just to problem solve a little bit. My slope is going to be 4 over 3. So that means I'm adding, for my rise, the top number, I'm going to add 4. For my run, the bottom number, I'm going to add 3. So if you use your proportion, you use your rise over your run, you can technically, as long as it stays in balance, we're really, really close. So 33 cups has a height of 51 centimeters. So I'm going to say really, really close. That's kind of an estimating equals kind of sign. So instead of 33 being a height of 51, let's say 32 cups for a stack of 50 centimeters. Because if it's 50 instead of 51 for our centimeters, it's going to be a little bit less for our cups. So I'm hoping the rise over run, the change in y, change in x, things that we've seen recently, I'm hoping that makes a little bit more sense, because we're going to see it on a graph next. So I'm hoping you're feeling a little more comfortable, okay? Again, pause it if you need to. Otherwise, I'm going to go to 5.3, okay? So it says 5.3, connecting slope to rate of change. I've talked about rate of change a little bit already. There's our 7-minute bell. I'm going to try to finish our lesson before my next class here. If you didn't create your own graph of the situation before, do so now. Well, if we backtracked before, we're going to have to find the first points. We know a couple points already. We know 6:15. We know 12:23. So I'm going to plot those couple of points. Number of cups is our x. Height in centimeters is our y. If I zoom in here, I know some of you are going to have a hard time seeing on your paper. 6:15. So let me mark every 5 for you. This is 0. This is 5. This is 10. This is 15. This is 20. This is 25. This is 30. This is 35. This is 40. Okay, be very, very careful. This is 10. This is 20. This is 30. This is 40. Okay, mark the numbers if you're not sure where you're at. So I'm going to go 6 to the right, 15 up. It's halfway between 10 and 15. This is 6:15 here. Okay? If you have a hard time writing it, you can show it on the side. The next stack that we knew was 12:23. 12 cups has a stack that is 23 centimeters high. Again, 10, 11, 12. So this is 12:23. If we took away 6 from our x's, that would be at 0. If we took away 8 from our y's, that would be at 8. All right. I'm sorry, that would be at 7. I'm going to have to erase that. So this is at 0, 7. So far we have those 3 points. If they ask us for something else, we're going to think about it. So the height, I'm going to kind of clarify this on the side. The height of 0 cups is 7 centimeters. That's what 0, 7 really, really means. Okay? 0, 7, 6:15, 12:23, if you can't read those points. What are some ways you can tell that the number of cups is not proportional to the height of the stack? Well, that would pretty much relate to starting at 0, 0. So the graph doesn't pass through. Zero, 0. It's not 0 cups, height of 0 centimeters. So it's kind of propped up 7 centimeters for that reason. So I'll say, so it's not proportional. So if you compared some ratios, it was, let me change the color real quick. The height in centimeters over the number of cups. That ratio is not staying consistent. 23 over 12, height being 23, cups being 12. It's not the same thing as having 15 centimeters and 6 cups. So it's not proportional. It could be proportional if we started at 0, 0, but it's not so far. We've already kind of talked about slope on the prior page. Slope is rise over run. So all those differences that we were doing +8, we were doing +6, right? The y-axis was related to our centimeters, and 6 was related to our cups. So we, again, kind of did this already. I'm dividing by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. So you could say every 3 cups that you add, you're adding 4 centimeters to your stack. So I'm going to put centimeters and cups here. Again, you're adding that to it. That's why it's plus. That's why your graph is going up. Okay, got 2 last questions here. Number 4, at what point does your line intersect the vertical axis? That means your y-axis. What do the coordinates at this point tell you about the cups? We kind of talked about that. We've talked about the point 0, 7. So that's touching the y-axis. You could say it touches the y-axis. The height is, I'm sorry, I did not label the y-axis part that I was talking about. The height is 7 centimeters with 0 cups. Okay? One last question, number 5. How much height does each cup after the first cup add to the stack? Well, we kind of talked about that already, right? We did talk about some stuff with our slope already. Each cup adds 4 divided by 3 centimeters to the stack. Those of you that love your decimals, if you put in your calculator, you're adding 1.33 centimeters to your stack for every single cup that you add. Okay? I'll be talking about our assignments tomorrow on Friday. It'll be a related assignment to our graphs that we were talking about. Okay? Very similar to Wednesday stuff too. Okay? All right. Let me know if you have any questions. We got our finals next week. I will talk to you tomorrow. And